Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today in this video, I'm going to solve one of the most famous, most frequently asked interview questions, that is the 01 knapsack problem. Now you must have heard about this problem. This problem is asked every year multiple times in a lot of top product based companies like Google, Amazon, Facebook and many more does ask this question in their interview rounds as well as coding rounds. So I'm going to solve this problem in this video. Now you must be thinking, this is a dynamic programming problem. We don't know. Doesn't matter. What you need to know is just basic recursion. If you know basic recursion, I'm going to explain you in such a way that you're going to learn dynamic programming with the help of this problem. So definitely watch this video till the end, and when you watch it till the end, you're going to learn dynamic programming. You're also going to learn how to solve a problem which is asked in Google or Amazon or such companies. Before that, let me introduce you myself. My name is Raj Vikramaditya. I'm generally known as striver in the programming community. I am a competitive programmer by nature. I am currently working as a software development engineer at media.net. Prior to this, I was working at Amazon, and I'm rated a candidate master at Codeforces. I'm also a 6-star at CodeChef, and I have 2+ years of teaching experience of competitive programming. I also run a YouTube channel which has around 90,000 subscribers. So the subjects that I will be taking going in future at Unacademy will be competitive programming, data structure algorithms, C++, and everything related to interview preparation. So without wasting any time, let's dive into the question. Knapsack. Yes. So basically there are n items which are numbered as 1, 2, 3, 4 dot 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 till n items. Okay, mark this point. Every item has a weight and every item has a value. Cool. So Taro, generally this name might change in a lot of problems. They might tell you this as a general. The famous version had thief, like chore. The famous version has thief or chore, whatever you can call it. So Taro has decided, or thief has decided, to steal or choose, whatever you can call, some of the n items. Like there are n items. Out of that, he has decided to choose some of the n items, or you can call it as a subset he wants to choose, and carry them home in a knapsack. Now what is this knapsack? Whenever a thief comes to your home to steal items, will he take everything in hand? ये लो, ये हाथ में रख लो, ये मांस, ये इसको भी हाथ में रख लो. हाथ से थोड़ी लेके जाएगा. चोर कभी क्या हाथ में पकड़ के लेके जाएगा? नहीं ना. What will he do? He will carry a bag where he can carry all the items. Correct? So that bag is known as knapsack. And obviously, if he is bringing in a bag, he cannot put in every item of the home in that bag. So that knapsack will at max have a weight of W. Cool. Now, W means whatever items he carries, that is the maximum he can carry. Okay. So you need to figure out what is the maximum possible sum of the values of the item that the thief steals or Taro takes home. You can just consider any of the version. So these are the constraints. Now remember one thing. In an interview, you will never be given the constraints. So never ever ask the interviewer, can you please tell me the constraints? Because the interviewer expects you to solve the problem in the brute force, in the naive way. After that, you analyze the time complexity, and then he'll tell you the constraints, and then according to that constraint, you'll optimize that. So at first, your main criteria should be to solve the problem. Doesn't matter. It can take exponential complexity, but your criteria should be, let's solve this problem. Okay, so let's quickly take up this test case, the first one where it says 330, 450, 560. Okay, so basically it says I have 3 items. Okay, and the knapsack has a weight of 8. I have 3 items. The knapsack has a weight of 8, and the 3 items has weight as, like, weight is an array. The first item has a weight of 3. The second item has a weight of 4. The third item has a weight of 5. Now there are values that are related to these items. So I can say the first item is 30, then it's a 50, then it's a 60. So that is what the values are for the corresponding items. Now the thief comes in. Will he, like, just remember one thing, this problem is known as 01 knapsack. Now what does this 01 knapsack means? Whenever a thief comes to your home to steal something, like let's say for this example, for this pen, if he steals this pen away, will he break it and steal the half? Obviously not. यार चोर चोरी करने आया है, पूरा लूट के जाएगा, आधा चीज तो नहीं लेने वाला, या फिर 25% 75% तो नहीं लेने वाला. He's gonna steal the entire amount. So he's gonna steal the entire item. So that is, when he steals the entire item, we call it as 1. When he doesn't steals, it's 0. So that's why 01 knapsack is the problem's name. So let's assume it has been said that the thief's gonna steal some of the 3 items. So let's assume he just steals the item 3. That is okay. So if he steals the item 3, he will have a value 30 that he's stealing. Probably I can say he can decide to steal the item 4, and if he decides to steal the item 4, he's gonna have the value 50. Probably he can decide to steal the item 5, and he's gonna have the value 60. Probably he can decide to steal something like 3 and 4. In that case, he'll have 50 as well as 30, which makes it 80. Now just asking you a very simple question: can he steal the item with a weight 4 and the item with a weight 5? No, he cannot, because the maximum weight allowed, as you can see, is 8. So he can definitely not steal away those things. So I know that he can definitely not steal. So that's not possible. So as I can see, if you try out picking up every possible like combination, the maximum that you will get is by picking up 3 and 5, and this will be 30 and this will be 60. So that's a summation of 90. So they want you to steal in such a way, they want the thief to steal in such a way that this value, that when you pick up the items, the summation of the value is as maximal as possible. And over here the answer is 90, and you need to print this maximum value. Now you might be thinking, array, this is so easy. The first solution generally that comes to everyone's mind is the greedy method. Yes, the first solution comes up greedy, because everyone thinks, array, main choru, I'm the thief, I'm gonna steal the maximum value item at first. So I'm gonna steal 60, that is the weight 5. So my weight was 8, the knapsack had a weight of 8, so I'm gonna steal 5. Then the next maximum value guy is this, but I cannot steal it because I just have a weight 3 left, so he'll not steal it. Next he'll try to steal this and he'll be able to steal it. That's the first solution, or the greedy, like sabse mehenga cheese, the costliest thing I'll steal. That's the first solution that comes to everyone's brain, and I'm gonna tell you that this is wrong. I'll be thinking, why is this wrong? चोर है यार, सबसे महंगा चीज ही ना चोरी करेगा. नहीं, the thief is smart and intelligent. चोर है भाई, वो हमारे जैसा नहीं है, मतलब सीधा कुछ भी करके चलाएगा, वो अपना प्रॉफिट देखेगा. समझ रहे हो? तो अभी प्रॉफिट वो कैसे देखेगा, मैं आपको I'll give you an example. So let's assume I have weights as 3. I have 2 items which has a weight 4, and I have item 5. Okay, so assume this is 60. These guys are 50 and 55, and this guy is somewhere around 30. Now I'm saying that there are 4 items and the knapsack has a weight of 8. So just imagine if you follow the greedy method that I said was wrong, then what will you do? You'll start off by taking the maximum guy, that's 5. So you'll obtain a value of 60. Then when you try to take 4, you cannot, because the weight is 8. Again you cannot take 4 because the weight is 8. And then you can take this 3. So you'll end up taking this 3, which will give you a total value of 90, which the thief can take. But what if I say the thief is smart and intelligent? And what he will do is, he will indeed take something as 4 and 4. He'll take the items with 4, 55 and 50. So he'll get a total of 105. Thief is smarter than you. Yes, he is smarter. He knows programming. So that is why he stole something as 105. So that is why following a greedy technique doesn't work. And in cases where following a greedy technique doesn't work, what we follow is trying out all combinations, or trying out all subsets that we can pick. Yes, we're going to try out all subsets that we can pick. Like as we saw that we can pick 3, we can pick 3 4, 3 4 4, something like that, right? So we are going to try out all subsets, and out of these all subsets, whichever subset rather gives the maximum summation of value, that is going to be my answer. So how do you try out all subsets? In order to do that, I think you know recursion, right? So you have to apply recursion. So let's quickly check out the recursion logic. So I'll just erase it. So I hope you have understood the entire question, right? So yeah, let's get started with the recursion logic. Cool. So when I say, let's take this example of n equal to 3 and we have a weight as let's say 8. And I take the first example so that I can just explain you how to generate all these subsets and then take the maximum of them. Okay. So this is 4, this is again as I said 50, and this is 5, this is 60. So these are the weights and this are the values. So in order to write a recursive solution, what we generally do is we always try to do in terms of indexes. Remember this. Whenever we try to generate subsets, we will try to do it as an index. So what we do is we have a function to whom we say start with the 0th index, correct? And initially you have just entered the home, so you are at the 0th item and your bag is not having anything, so that's a weight 0. So start. So you go across to this 0th guy, right? This is the 0th index guy. You go across to this. As a thief, what do you do? You have an option of either saying ki, let's steal that and put into my bag. Yes. So if I steal that and put it into my bag, can I say I'll add a value of 30? I can definitely say that. So let's put it into the bag. Can I say if you have stolen the 0th index item, you will move to the first index, correct? And if you move to the first index, can I say if you have stolen this, the weight, the knapsack weight will be filled up with a value, rather something like 3, because the weight is 3. So I move to the first index and the knapsack gets filled up with a weight of 3. Now the thief could have said, hey, I'm not interested in stealing this item. So what he'll do is he'll say, I'll not pick this, I'll not steal it. So if he doesn't steals, the value addition that he does is plus 0. And if he doesn't steals this 0th index, he will say, okay, let me move to the next and then probably I can check out the other items. So he'll move to the next, and if he doesn't picks, the weight still remains as 0. So this is the first level. You're going to try every possible combo. This is how you do in recursion. Cool. So imagine f is nothing but a recursive function which you're calling again and again and again. You should have prior knowledge of recursion, as I said. So over here, you're at the first index now. Again, if I ask you, what can you do at the first index? I'll be like, again, I'll do the same thing. Either the thief will steal it. So what if the thief steals it? So he'll have a value addition of 50, correct? He'll have a value addition of 50. And what he'll do is, he'll move to this next guy. And the addition to its knapsack will be 4. So the total weight of knapsack from 3 will become 7 because the weight is 4. What if he doesn't steals? Then there will be a value addition of 0. And he will move to the next index with the knapsack weight as 3 because it did not steal. So this is how, yes, this is how you're going to do at the second index. Now you come to the second index. Can I say, I again perform the same thing, either steal or not steal. So you're getting a pattern, steal or not steal, correct? So he decides that he's going to steal the second item. If he decides that he's going to steal the second item, he'll do a value addition of 60. Am I correct? I am correct, indeed. So if he steals, he will reach the third index and his knapsack will become 12. Now over here, you'll be like, hey, this is not possible because the knapsack was stating that he can have a maximum of 8 weight. So when you call this recursion, this saw that, hey, you're coming in with a greater weight than your knapsack, so you cannot come in. So what he'll say is, hey, can you please return? One of the base cases, if the weight of the bag exceeds, yes, if the weight of the bag exceeds, it's going to say, can you please return? And since you did a value addition of 60, I'm going to say, you're not possible. This is not possible. So you're going to return a very, very smaller value, probably in range of 1e9, 1e18, a very smaller value, so that it doesn't get calculated to your answer. So you return this, correct? Now what if you do not pick? If you decide you're not going to pick, in that case, what will happen? You will come to the third index, obviously. So let's come to the third index. And the knapsack will be 7. Now when you come to the third index, that's ideally this index, which is non-existent. So you have actually decided for every index. And if you observe, you're saying pick, pick, not pick, or steal, steal, not steal. So ultimately, this guy is a valid. So he'll say, okay, I have ended and my value addition is 0. So he gets back. Now f of 27 says, which one from 2, when I was standing at the second index, did stealing give me the greater, like if I am at the second index and मैं आगे देख रहा हूँ, क्या चोरी करने से ज़्यादा profit है? Is stealing giving me the greater profit, or is non-stealing giving me the greater profit? I saw that not stealing gave me a greater profit, because if I stole, my knapsack bag would have rusted, right? It would have gone out of capacity. So this guy gave me the better one. So he said, do not steal, and that's 0 addition. That's 0 addition that it gives you. Okay, basically backtracking, you're moving up now. Cool. Now let's do the next portion. Now you're over here. Over here again, you have a couple of options, either to steal or either to not steal. Now imagine you decide to steal, then there will be a value addition. The second index is what you're stealing. The value addition will be 60, correct? And if you steal, you'll say, I'll go to 3, and the 3 weight will become 8. Perfect. That is okay. So you have reached the third index. That means you have ended up stealing everything, or ended up looking over everything, and you've decided what to steal and what not to steal. And if you carefully observe, steal, not steal, steal. So this guy is going to say, it's over, please return 0. So you are standing at 2 and you're saying, I have a 60, and if I steal, I get 60. I'm standing at second index, I'm saying if I steal, I get 60. And if I do not steal, I'll go to the third index and my weight will still be 3. So I've reached the third index, so this is going to return 0. So if I steal, I get a 60, and if I do not steal, I get a 0. So what will you prefer, stealing or not stealing? I'll be like, stealing is what I'll prefer. So he'll steal and he'll give him the value 60. So the maximum of stealing and non-stealing, you got a 60. Now you are at the first index. Over here you saw, if you stole, you got a 50 plus a 0. So that's a 50 if you steal. And over here, if you do not steal the first index, you got a 0 and you got a 60, which makes it 90. Which makes it 60. So I can say, if I'm at the first index and I decide that first index will not be stolen, then I get a maximum value of 60. Perfect. So as of now, you are at f of 0, 0. So this, when you are at the 0th index, if you steal, then that will give you 30. And beyond that, the maximum that you got was 60. So in total, this guy will give you 90. So when you started, and if you decide to steal this 0th guy, you will get 60 plus 60 plus 30, that's 90. So from the left, if you steal, you'll get 90. So similarly, you can do for this guy. The right recursion tree can be fully completed. So I'll just quickly complete it. So again, I can steal. So if I steal, I'll get a value addition of definitely 50, and I'll move to the next index, and the weight addition will be 4, and I can definitely not steal. So that will be a plus 0 value addition. I'll move to 2, and I'll have a 0. And if I decide to again steal the second index, I'll have a value addition of 60, but there will be a problem of weight. The weight will become 9. So this is not possible. So it's going to return a negative value. Yes, it's going to return a negative value. So if it returns a negative value, if you steal, you get a negative. तुम्हारा value कम जा रहा है. The value is reducing if you get a negative, correct? Now if you decide to not steal, you'll go to 3, 4. So this will return a 0. So if you steal, you're getting a negative, and if you do not steal, you're getting a 0. So ultimately this guy gives you 0. Yes, this guy gives you 0. So now let's check this guy. And if you decide to steal again, you're gonna go to 3. The value addition will be 60. I'm just doing it super quick. You people can definitely try it at home. So this is going to be f of 3, and you're not stealing, so this will stay as 0. So if you're not stealing, this gives you 0. This is plus 0. And this is when you reach end. So that's 0. So if you steal, you're getting 60 plus 0. If you do not steal, you're getting 0 plus 0. So what will be your preference? You're saying your preference will be 60. So over here when you're standing, if you steal, it's a 50 plus 0. And if you do not steal, it's 0 plus 60. That's a 60 value. So what you will do is you will take the steal value, not steal value, that's 60. So from here 0 plus 60 gives you 60. So if you steal, you'll get 90. If you do not steal, you'll get 60. When you're starting at 0th index. Start at 0th index, steal gives you 90, not steal gives you 60. Which one will you prefer? The answer to that will be 90. So I can say my answer comes out as 90. Yes, 90. So if I summarize, like if I just break it down to sub problems, can I write it as sub problems? Yes, I can. Can I say if I'm standing at an index, assume this is an index and I'm currently having a weight as W, can I say the value addition that I am doing is nothing but the value for the current index. If I steal that value, I'll add and I'll say I will move to the next index. Now this is recursion, he's gonna solve it himself. As you saw, you took 30 and you called f of 1 3, it went down 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 and it solved, correct? So f of index plus 1, can I say that W will add weight of index? I can definitely say that, right? Or can I say if I do not steal, in that case the value addition will be 0 and I'll move to the next index, but the weight of knapsack will be W itself. So can I say these are the two recurrence that I can write if I am thinking of a recursive solution? Indeed yes, indeed yes. And if these are the two recurrence, which one will the thief prefer? The maximum. So that's how you get a recursive recurrence. So once you've got the recurrence, you can definitely write the recursive solution, and after that we have to memorize, right? But before coming to the memorize, if you write the recursive solution, what will be the base case? You have to think about the base case. I can say the thief is stealing. Can I say the one base case that I notice is every time he reaches 3, as you can see, that's when he stops stealing or not stealing. So I can say one of the base cases can definitely be something like if my index, or if I use some other color, if my index reaches n, that's one of the base cases. And if it reaches, I know one thing, that I'm going to return a 0. As you saw, I returned a 0, I returned a 0 everywhere. But I can put a one more base case. If you look at this condition, when you came to 3, before this, if at any moment you're stealing, and the weight of your knapsack exceeds the weight that was given to you, in that case you'll say value addition is negative, so that guy is not considered. You will return a negative guy. Yes, you're going to return a negative guy. I hope that makes absolute sense to you, right? So that is how you will write it. So if I talk about the code, I'll just write the pseudo code. So can I say the pseudo code will be, I'll take the index, I'll show you the code in Sublime, but as of now let's talk about the pseudo code. So index and weight will be taken, right? Or you can probably keep it as W. And what I know is if the weight exceeds the given weight of the knapsack, I'm going to return a negative value, very bigger value, something like 118 or something, a very big value, so that value addition is never done, correct? And can I say if I reach the last, that means I have decided which one to add, which one to steal or not, and I have been in my limit of knapsack. So I can return definitely a 0, or else I will decide I'll steal, and the steal is very simple. If I steal, the value addition will be value of index plus f of index plus 1 comma w plus wt of index, because you're deciding that you're going to steal, correct? So you've done it. If you say not steal, what will be your value addition? 0 plus f of index plus 1, you'll move to the next index and you'll still have the same weight. You'll still have the same weight of the knapsack because you did not steal. And at the end, can you say you will return the max of steal and a not steal? Indeed you will. So that's how, yes, that's how you can write a recursive solution. Now the stuff that I wanted to tell you is, remember one thing, it's always steal and non-steal in these kind of questions. If the question is tweaked, make it like pick and non-pick. Either आप उठाते हो या फिर नहीं उठाते हो. Generally सारे questions पे यही pattern follow होता है. ठीक है, तो इसको ध्यान रखना. Cool. Now we have written the recursion solution. Now what is the time complexity? As you know, since I'm trying two possible stuffs for every index. So if I say there are three indexes, can I say I'm trying two possible stuffs for first index, that's steal and non-steal? Two possible stuffs for this index, that's steal and non-steal. Two possible stuffs for this index, that's steal and non-steal. Can I say the overall time complexity will be 2 to the power n, because I'm trying 2 cross it, 2 cross it, 2 cross it, 2, right? So that's 2 to the power n, again exponential in nature. So this is the moment when you look at the constraints. So if you check out the constraints stated, oh my goodness, n is 100. So if I just write the constraints, n is around 100, man. 2 to the power 100 will overflow. Like 2 to the power 100 is so much, man. So this was going to give you a TLE. So remember, in order to remove this TLE, if you convert a recursion to a dynamic programming solution, that works. And in order to do that, you just have to use something which is known as memoization. Now, when is this memoization used? When there are overlapping subproblems. I repeat, when there are overlapping subproblems. Now, you might be thinking, what is this overlapping subproblems? For that, again, let's take an example so that you get a better idea. Okay. So let's take one more example. So I'll take WT. Let's take the weight as 1 cross it 1 cross it 1. I'll just quickly do it, and I'll have a value as 10, 20 and a 30. Okay, and the knapsack is given as 3 items, and the knapsack weight is given as 2. Okay, so initially you know, right, how to do this. Initially you'll start with f of 0 0. What you'll do? Steal. If you steal, there'll be 10 addition. If you do not steal, there'll be 0 addition. If you steal, you'll go to the next index with a bag weight of 1, correct? And if you do not steal, you'll go to the next index with a bag weight of 0, right? Again, if you decide to steal, there'll be a value addition of plus 20, and you'll be like f of the second next index, and the bag weight will be 2. And if you do not steal, you'll move with a plus 0 addition to 2 comma 0, correct? Sorry, 2 comma 1, right? Again, if you decide to steal, so that's a value addition of 30, and you'll end up reaching at f of 3 comma 3. Obviously this will not add up to your answer because the weight has exceeded the given knapsack. So if that happens, you're going to return something as a negative, like a very big negative value, so that this is never considered. So probably 10 to the power minus 18 or something like that. So if you do not steal, in that case the value addition will be 0, and it will be like 3 comma 2. So this will return a 0. So if it returns 0, this guy, f of 2 is going to get a value 30 plus negative 0 plus 0 0. So this guy will give you a value 0. You take the maximum of steal or not steal. So 0, you'll take it off. Okay, cool. So you have an f of 2 comma 1 over here, right? So if you decide to steal, so that's going to give you f of 3 comma 2. So that's a value addition of definitely 30. And if you decide to not steal, you'll get a 3 comma 1. So this is going to return a 0. This is going to return a 0. Which one will you prefer? 30 plus 0, or a 0 plus 0? Which one will you prefer? Obviously 30 plus 0. So this guy will return. So this guy will get a value 30. Correct? Now if I quickly write this guy, so that's a 20 plus 0, which is 20. This is 0 plus 30, which is 30. So if you steal 20, if you do not steal 30, so this one guy 1 comma 1 is going to get your value of 30. Perfect. Now you will be like, yeah, what is some overlapping subproblems? I'll tell, don't worry. So over here, if you decide to steal, you'll get a 2 comma 1, and if you decide to not steal, you'll get a 2 comma 0. This is where you realize overlapping subproblems. Do you see 2 comma 1? Yes. Do you see a 2 comma 1 here? Yes. This is what is known as a overlapping subproblem. If you have same recursive calls, don't you think if you have same recursive calls, if you call for f of 2 comma 1, the answer that you got as 30, and if you again draw the recursive tree from 2, you'll again get it as 3, you'll again get it as 30. So this is where you can use caching or probably hashing, where you say I'm going to store in some dp table. Probably assume this is a dp table where I'm storing, this is 2 comma 1, right? So 0 1 2 and this is 0. So at 2 1 I'm going to store 30. So I've stored this value. The moment this was computed, I've hashed it. So over here when I come across, I'm saying 2 comma 1, right? So will you draw the tree and again do the recursive calls? No. Indeed, you'll go to the dp table and it'll say 30 and you'll return. This is what is known as overlapping subproblems. I took a smaller example. That is the reason you saw a very limited overlapping subproblems. But if these guys are very high, the number of items are very high, you'll see a lot of overlapping subproblems, and hence it can be optimized. Now you won't be doing 2 to the power n recursion calls. Yes, because at maximum, if this is the dp table, the number of cells will be the time complexity, because that many recursion calls will come and those many values will be stored. So at max those recursion calls will be done, correct? So how will you memorize this? It's a very simple funda. It's a very, very simple funda. Now I'll teach you this and you need to remember this forever. Okay, so I'm not going to teach you that. So what am I writing? I'm writing an index and I'm writing a w. So I have to memorize index as well as w. So I need a 2D array because there are two parameters which are changing, index and w, correct? Now if I just scroll, what's the maximum value index can have? Can I say it's an n? Yes. What's the maximum value that w can have? So if you check out the constraint, it's around 10 to the power 5. So I can say the maximum value it can have is 10 to the power 5. Okay, so if I have a 2D array of n crossed 10 to the power 5, can I, every time I'm having this guy computed, can I actually store it? Yes, I can. And this is what is known as memoization. You store it, you store this value into this dp table. What is dp? Using the past, right? So that you don't have to repeat in the present. That's dp. So in the past you figured out 2 1, you use this value and you, instead of going again, you used it. So these are the number of n crossed 10 5 is the number of maximum states we can have, or the number of maximum recursion calls we can have. Hence the time complexity will be big O of n cross 10 to the power 5, क्योंकि इससे ज्यादा तो कॉल्स होंगे नहीं. लाइक रिकर्शन n क्रॉस 10 to the power 5 छोड़ के क्या ही स्टेट्स बुलाएगा, एंड बुलाएगा भी तो मुझे डीपी टेबल से तुरंत मिल जाएगा, मुझे को वेट नहीं करना पड़ेगा. I'll get it immediately from the dp table. So that's a constant operation. The space complexity becomes big O of n cross 10 5. And how do you convert a recursive solution to a dp solution? Like this is the recursive solution that you wrote, right? How do you convert that? Let's now check out the code. If you check out this code, I've already pre-written it because the video is already long, so I've just written it. So you've taken nwt, that's sweet, and make sure that everything is long because I've checked out the constraints, and as you see the constraints are n is 100, w is 10 to the power 5, values at 10 to the power 9, so it might exceed. That is why to be safe I've taken everything as long, correct? So if you check out, I've taken nwt globally declared, then I've taken the inputs, then I've made sure that the dp is -1. Now why have I made sure that the dp is -1? Abhi, whenever the first time the call comes, if you haven't computed, how will you know? So initially the hash values are -1. If it is -1, that means abhi tak answer has not been computed. I'll now go and compute. Okay, so everything is -1. I call the function with 0 0. You remember f of 0 0 शुरू किए थे पुराने दिन, याद है ना? F of 0 0 से will start. So when we start, these are the base cases I wrote in the recursion. Forget this line. This is what I wrote in recursion, correct? Value of index, f of index plus 1, and the weight addition, and this is if you don't steal. And I took the maximum. Now remember, the highlighted part that I show, the highlighted part that I'm showing is nothing but the function ka answer, the function ka answer, right? So what you'll do is you'll just hash it. This is the step that is used as hashing, or you can say is this is memorize. You're memorizing it. Okay, so you memorized it. Now every time a call for index weight comes, before actually calling this recursions, because before going to left and right, you'll check पहले तो like previously someone तो computed नहीं किया था, and if someone has previously computed, you'll return dp of index and weight. You'll return dp of index and weight instead of calling a left and a right. Yes, so this is how dp can be implemented. Write a recursion, then simply add these two lines. If previously occurred, return, and whenever you compute, store. Two lines. Adding two lines converted a 2 to the power n solution into n crossed 10 to the power 5 solution, and this is what is known as a dynamic programming. आज तक डर लगता होगा, अब नहीं लग रहा होगा, मैं श्योर हूं, है कि नहीं? कमेंट सेक्शन में बता देना, डर चला गया ना? So now what is the maximum value of n according to the constraints? The constraint stated that this is 100 and the weight is 10 to the power 5, so that's near about 10 to the power 7 operations, which is going to be executed under 1 second. If you are doing competitive coding, it's okay, it's very good solution. So we have solved this problem, right? So I hope you have understood 01 knapsack, but now I have something special for you. So there are a number of new batches that are going to be launched at Unacademy. Something like system design, where we cover LLD, HLD with real world case studies, which has gone live on 21st of June and has a 2 months duration. Backend development, where we teach from fundamentals to career readiness, which has gone live on 22nd June. Similarly, computer fundamentals, which has a 4 months duration, and full stack development, which has a 4 months duration again. So these batches are live now, so you can go check it out. And if you are feeling like to take it up, I'll highly recommend that you should definitely try out the Plus subscription, because this was a recorded lecture, right? You could not ask me doubts. What if you had some doubts while I was teaching? So in that case, you'll be requiring live classes. So at Plus, all these educators, including me, will be taking live classes. So you can definitely ask them, and trust me, these are India's best programmers. You saw my credentials. There are people who are having similar credentials as well as better credentials at Unacademy Plus. So definitely check them out. And yes, with this, in Plus, you're getting a teaching assistant, a lot of teaching assistants who are going to clear your doubts. So the doubt support is amazing, and we just solved knapsack. So if you're at Plus, I'm going to give you a lot of relevant problems that you're going to solve at CodeChef. So you're going to get a lot of bunch of problems that you can definitely solve. And if you're willing to take up a subscription, please make sure to use the coupon code STRIVER. Yes, you're going to get a 10% discount. मतलब भूलना ही नहीं है, ये कोड तो यूज करना ही है, ठीक है? अभी अगर चैनल पे नए हो, अभी तक सब्सक्राइब नहीं किया, कर दो. मस्त लगा ना एक्सप्लेनेशन? ऐसे ही एक्सप्लेनेशन I'm gonna bring, ऐसे ही इंटरव्यू क्वेश्चंस मैं इधर लेके आने वाला हूँ, बट उसके लिए घंटी बजा के रखना होगा, क्योंकि जब भी मैं या फिर कोई भी और ऐसे एक्सप्लेनेशंस डाले, आप आके देख सको. सो अगर पूरा वीडियो देख लिया एंड यहाँ तक मतलब समझ आ गया ना, आ तो गया होगा, एंड अभी तो लग रहा होगा गूगल अमेजन ईजी है. अगर लग रहा है, अगर लगता है कि भाई क्या क्या है डायनामिक प्रोग्रामिंग, कुछ नहीं है, अगर ये फीलिंग आ रही है तो लाइक कर देना एंड कमेंट में बता देना कि कैसा लगा. एंड यार और एक चीज़, इंग्लिश, हिंदी, इंग्लिश कौन सा चाहिए कमेंट सेक्शन में पक्का से बता देना. इसी के साथ इस वीडियो को रैप अप करते हैं. बाय बाय, टेक केयर.